So in this video you can go over on how you can be able to factorize the expressions. So what is to factorize? Now this is the process where we are actually putting things in a groups. So that is to factorize. So in all cases actually there are several techniques in which the factorization can be actually done. Now we have what you call the common factor technique. So what is a common factor technique? Now should be the common factor technique. So now if we say the common factor, if we say the common factor technique, this is the actually a technique in which given the typical actual expression, we just look at the highest common actual factor and for the given terms. And for instance, let's say if we have 2x squared minus, let's say, 5x to the power 3. So what is the highest common factor for the 2? So you can see that we have it as x squared. So have x squared and that 2 minus 5x. So that's how the common actual factor technique works. So again, to understand how all these processes works about, I just have to understand that run up to. And what is another technique of factorization? We have what we call the difference of two squares. So that is, let's say if we have a to the power 2 minus b to the power 2. So in this case, since this is the different two squares, that is a to the power 2 and b to the power 2, now we'll have it as a plus b in that terms a minus b. That's how it works. Let's say if we have, let's say, x squared minus 36. So you have to ensure that the expressions that we have, or the values that we have for the different two squares, are perfect squares, in the sense that x squared is the perfect square and 36 is also part of the perfect square. We can be able to express that on to have power 2, have it as x squared minus 6 to the power 2. Now this one is corresponding with this one, in the sense that we'll have it as x minus 6 in the terms x plus 6. So that's how we should have to understand about the different two squares as one of the technique of factorization. You understand much about this one now for the upcoming examples. And we also have what we call try and error method. So in the try and error method or technique, now this technique, this expression is a given in terms of the quadratic expression, and it can also be that of a cubic expression, but basically it deals with the expressions that are quadratic expressions. So where we actually factorize using the way we actually factorize the quadratic expressions. And for instance, let's say if we have x squared and plus 2x minus 3. So we can be able to factorize this one the way we factorize the quadratic expressions, in the sense that we are to look at the factors of negative 3 that upon adding will have a positive 2. So in that case we'll have it as x squared and plus, now should be a 3 and a minus x minus 3. So you can have it as x plus 3 and a negative 1 and x plus 3. That will be given as x plus 3 and x minus 1. So this technique is actually somewhat easier because we use the concept of factorization of the quadratic expressions. So you understand how this technique also works for the upcoming examples, but just have to bear that in mind. And now we also have another technique, that is a difference of two cubes. So what is a difference of two cubes as the technique? Now let's say we have a to the power 3 minus, let's say, b to the power 3. Now this is what we call the difference of two cubes, where we're having the expressions and both with the highest degree power given as 3. So how do we factorize those cases? So now, according to the principle behind, we'll have it as a minus b, and at times now we'll have it as a squared plus now should be ab and plus b squared. So that's the principle behind it, in the sense that we actually have the difference of the two actually bases, then we square the first value and plus the product of the two bases and square the other value. So that's the principle behind the difference of two actual squares. And how about a sum of, actually should be different two cubes. How about the sum of two cubes? Let's say for instance we have a to the power 3 plus b to the power 3. How do you factorize this expression? So in this case we have it as a plus b becomes a squared, and that of minus ab and plus b squared. So that's the principle behind the actually the different two cubes as well as the sum of two cubes. So keep that in mind. And finally we have what they call the grouping technique. So what is the principle behind the grouping technique? So in this case, we do given the random actually values, and that can be 3 or 4. Let's say we have this case, we have x squared and plus let's say 5x minus let's say 7. So how should we be able to, let's say should have it in this case, let's say minus 7 and plus let's say 14, let's say y. So now how should we be able to factorize this expression using the grouping technique? So then you should just have to look at the values with the common factors. Let's say we have this and this one, and also this and this one as well. They're having the common factors, so just have to group them. Let's say in this case we have 5, should be x times x plus 5. That way the minus 7 as the common actual factor there. We'll have it as 1 plus 2y. So this is how the grouping technique works. And for example, let's say if we can also have this case as well. Let's say we can have, say, x cubed, and let's say minus x squared, and plus x minus 1. Let's say that's the case. How should you have to use the grouping technique to factorize this expression? So principle means the same. This and this, and this and this as well. In this case we'll have it as, what is the highest common factor in that case? We'll have it as the x squared. So we'll have x minus 1 and the plus. In this case we'll have it as 1x minus 1. So now you can see that in both the groups we have the common active factor as well. Hence we'll have it as x minus 1 times the x squared plus 1. So that's how the principle behind the grouping techniques actually works. So now let's have to understand about some of the different problems you have to understand about that you factorize. Let's say we have x squared minus 49. How should we completely factorize this expression? So you can see that the x squared is the perfect square, and the 49 is also part of the perfect square. In other words, 49 can be expressed to have power 2, in the sense that this is the same as x squared minus 7 to the power 2. Now according to the principle behind the factorization of the different two squares, now this is the same as x plus 7 times x minus 7. That's how it works. And let's say we have this case, let's say have 2x and minus 5b, let's say to the power 2, and let's say minus 36. Now how should you be able to completely factorize this expression if this is the case? So according to the principle behind, as you can see, we have two terms, this one as well as this one, and all these are the perfect squares, in the sense that we can be able to express 36 to have the power of 2, or have it as 2x minus 5b to the power. You should have to regard the whole of this expression as the, let's say, the way you can have to regard it as being x. So minus 6 to the power 2. Now this is the same as 2x minus 5b and plus 6. that is in the terms 2x, actually 2x minus 5b and the minus 6. So that's the working principle behind that in that case. So keep that in mind. And how about if we have, let's say, in this case, let's say if we have the problem that goes like, let's say if we have, let's say 2x to the power 3 and that minus, let's say 50x. Now how should we be able to completely factorize this expression? So now on this and this, what is the highest common factor? We have it as 2 and also x. So you have x squared minus 25. So now as you can see in the brackets we have the different two squares, so which means we can have it as 2x and x minus 5 the times x plus 5. So that's how you know it. So you need to have the critical group and see what's the problem is about. Let's say if we can have this as well. Let's say we have 3x to the power 5, and let's say minus 3x in that case. So what is the highest common actual factor in this case? So we have 3 as well as the x. So have x to the power 4 minus 1. So you can see that these are different two squares, and of which you can have it as, let's say, 3x and at times now have x to the power 2 minus 1. Now should be that times x to the power 2 should be now plus 1. So keep that in mind. Now in this case we can further factorize this one because that's also different two squares. We can have 3x, you have x plus 1 times x minus 1 times x squared plus 1 and just that. So this one cannot be actually factorized because that's not the different two squares. So it is said to be a reducible expression, the expression that cannot be factorized. So take note of that. And let's say if we can have this as well. How can we factorize this? Let's say if we have x squared and minus 4x, and let's say minus 5. So how can we factorize that one? We use the actually principle behind the try and error method or the technique. So think of the factors of negative up to 5, and that when you add will give you negative 4. So in that case we'll have it as x squared and minus x and plus 5x and minus 5. So in this case we'll have it as that of x and x minus 1 and the plus 5x minus 1. So that's the same as x minus 1 and the times x plus 5. So that's how we factorize that one. And how about, let's say if we have this case, let's say we have a plus, let's say b to the power 2, and let's say minus, that should be a plus, let's say b, and let's say minus 5. Now how should we be able to factorize this? So now first thing we should have to expand this, and also should have to expand this, then see the way forward. So try to have that out at your own time. You also think about this one as well. What if we can have this? Let's say we have, let's say 2 to the power x to the power 4, let's say plus 9, x to the power 2, and let's say plus 4. So how should we be able to factorize this expression? We also use the try and error method. We should have to multiply actually 2 as well as the 4, and think of the factors of 8 that when you add will give us actually 9. So have 2x to the power 4 and plus x to the power 2 and plus 8x to the power 2 and the plus 4. So in that case we'll have it as should be x to the power 2, and we'll have 2 x to the power 2 and plus 1 and the plus now have 4, now should be 2 to the power 2 and plus 1. That's how it will actually work. So now we have the common actually factors there. So in that case we'll have it as 2x to the power 2 and plus 1 times x squared plus 4. So that's how you have to understand that and up to in that case. And how about if we may have this case as well? Let's say if we have x to the power 2 and plus, let's say 2x and plus 3. So now let's see if we can be able to factorize that one using try and error technique. So you can see that we cannot be able to factorize that one. Let's say if we have x to the power 2 and plus 9. So now we do not have the factorization of actually the sum of two actually squares. Now let's say we have this case. We have x to the power 2 and let's say minus y to the power 2 and plus 10x and let's say plus 25. So how should we completely factorize this expression? So now you can see that if we continue to group these actually terms, of course you may think of having this one and this one. Of course you can factorize in this one you can also be able to factorize. Let's see, you can have it as, now these are different two squares, so in that case we'll have it as x minus y. You have it as x plus y, and of course plus, what is this? You have it as actually 5, you have 2x and plus, and that should be that of 5. And of course that's the way out, but it is not a complete, so we need to factorize this one completely. So how should we further go about that one? So now we should have it in this way. So we can have it actually being grouped in this way, where you can have actually to group x squared and plus 10x and plus 25, because this expression can be factorized using the try and error technique. So in the sense that we'll have it as x squared and plus 5x plus 5x and plus 25, and in that case you have it as y to the power 2. So have it as x and x plus 5 and plus 5 x plus 5 and minus y at the end there. So that is the same as x plus 5 and times x plus 5 and minus y squared. So since these expressions are the same, then this is true. We can have it as this now. We'll have it as x plus 5 to the power 2 minus y squared. So now you can see that we have different two squares. So try to proceed that and up to. We should have to see how best we can go over that one, but that's the principle behind. So be careful whenever we are using the grouping technique. We may end up having incomplete factorization. That cannot work. Let's say if we have this case, let's say we have, that should be ax, that should be ay rather. Let's say have ay and plus Now I should have it as ax squared, let's say, plus b actually y, let's say, plus b actually x squared. So how best should you have to cover that and factorize if this is the case? So now we should have to group them this way and direct that. So in this case we'll have it as a y plus x. Now should be like this. Now should be like that, and the plus we'll have b in the y plus x squared. So now you can see that we have the actual expressions that are the same in the groups. So which means this is the same as y plus x squared, and that times a plus b. So that's the principle behind that. And how about if we have this case? Let's say we have x to the power 3, let's say minus 9. Now should be minus 8 rather. So how should we be able to factorize this? So now you can see that we have a cube as well as 8 is also a cube. That is a perfect cube. So we have the different two actual cubes. That is the same as x to the power 3 minus 2 to the power 3. So what is the principle behind factorization of the different two cubes? So as we already talked about that, in the different of two cubes is factorized in the sense that we'll have it as, now we'll have it as x minus 2, direct that times x squared, and plus 2x, and that should be that, and plus 4. That's how we're going to factorize that one. The match has, that's the different two cubes. And likewise, if it could be the sum of two cubes, like let's say we have x cube and let's say plus 125, how should we be able to factorize that one? Now we have the sum of two cubes in the sense that we can have it as x to the power 3 plus 5 to the power 3. So the principle behind the sum of two cubes will be given as x and plus 5 like that, and that times now have x squared minus now have 5x and plus 25. So that's the working principle behind factorization of the sum of two cubes in that case. How about we can have this? Let's say if we have 8 and plus, let's say, should be x minus, let's say, 5. So how should you be able to factorize this? So now we have actually the sum of two cubes, as you can see. So what is the working principle? Which means we can have 2 to the power 3 plus x minus 5 to the power 3. So which means we'll have it as, what is the principle behind the sum of two cubes, as we have already expressed that on up to. So which means we'll have it as now 2 plus x minus 5. That should be like that. Then we'll have 2x, that will be given as 4. 2 to the power 2, that actually 2 to the power 2, that will be given as 4. And minus should be minus. We'll have 2 times x minus 5, and I should have it as a plus, then x minus 5 to the power 2. So that will be given as, we can be able to simplify this. We'll have it as x minus should be 3, and 4, and that should be minus x plus 10, and the plus, you'd have to expand that on and have it here, then you can be able to simplify that one out. You have the expression inside there. So try to go over that one at your own times. Now what if we have this case as well? Let's see if we can have this. let's say if we have 125 that divided by m to the power 3 and n cube, and let's say minus 1. So what is the working principle behind this? That's now different 2 cubes, in the sense that this is the same as now 5 to the power 3 divided by m to the power 3 and n to the power 3 as it is here. And of course we can have it as this. So we'll have it as mn over the power 3 and the minus 1 to the power 3. So now try to have that out as far as the different 2 cubes is concerned. So take note of that. And let's say if we can have this. Let's say if we have 25 and divide by 16 minus, let's say, c to the power 4. So now this is the same as having it as, now should be 5 to the power 2 divided by 4 to the power 2 minus c to the power 2 and over to the power 2. So we have different 2 squares in this case. That will be given as 5 over 4 and minus c to the power 2, like that, and I'll have times 5 over 4 and the minus c should be a plus c to the power 2. So that's the working principle behind that, as you can see. And let's say we have this case as well. And let's say we have a to the power 2 plus b to the power 2. So this one can't be actually factorized. We do not have the factorization of the actually sum of 2 squares. And also at the end time, try to have the following problems. And I should have to see how we can be able to factorize that one up to. Let's say you have x to the power 4 and plus, let's say 2x square plus y square, and let's say plus y to the power 4. Try that one out. Let's say if we can have, let's say x to the power 4 as well. X to the power 4 plus x square y square, and that should be that, and plus y to the power 4. Try to have that one out at your own time as well. And how about this one? Let's say if we have x to the power 6 minus y to the power 6. So how should we be able to factorize this? And of course, having this, it is the same as x to the power now 2 over the power 3 the minus y to the power 2 over the power 3. Now we have different 2 cubes. So we should have to try to have that one out in that order. Let's say we have b to the power 3 and minus q to the power 3 and minus b, and we have b to the power 2 minus, let's say, q to the power 2, and just that plus q and b minus q and over the power 2. How should you be able to factorize that one up to? So try to have that one at your own time as well. And also try to go through this if it is possible. Let's say you have x squared and plus 10x and plus 6 should be 16. And try this one as well. Let's say if we have x to the power 4 and minus 9x to the power 2 and plus 20 as well. What is that? Let's say if we have 1 over, let's say, 36 and minus, let's say, m to the power, let's say to the power 4 minus 16, let's say, times x to the power, let's say, now should be a 6. So try to have that one out and how you can be able to factorize that one in that case. And also think about this one as well. Now what if we have this? Let's say if we have x to the power 4 minus, let's say, 4x squared and b square and c square and plus 4 b to the power 4 c to the power 4. Try to have that one as well at your own times. So thank you.